Good morning. In this video, Thermoplastic Polymers Part 3. In the Thermoplastic Polymers Part 1 and Part 2, 12 thermoplastic polymers have been discussed. In this video, two thermoplastic polymers PEEK and PTFE and two thermosetting polymers Urea formaldehyde and Phenol formaldehyde is presented. The 13th one, PEEK. PEEK is nothing but polyether ether ketone. So PEEK, the structure of PEEK has two benzene rings with two oxygen bond and OO and CO group, three benzene rings and two oxygen bonds and CO group. PEEK structure is similar to some of the other high temperature plastics. These plastics are fairly new and have come to markets from 1994 only. Properties of PEEK. PEEK is highly crystalline, similar to metals, and hence its mechanical properties are much better than other plastics. PEEK has excellent resistance to attack by hot water and low pressure steam. So it can be used as containers for hot waters. Resistance to water and many chemicals. When PEEK is used as matrix resin for FRP composites, the resulting composite will have high modulus of elasticity, which makes a composite much stiffer than aluminum. PEEK is very expensive. Applications of PEEK. PEEK finds use as blow molded containers for nuclear waste, printed circuits, electrical appliances and wire coatings. As PEEK has higher tensile strength, it finds applications in aerospace and aircraft applications. PEEK filaments are used for making clothes and garments. Then the 14th one, PTFE, polytetraflouro ethylene. So it has a structure similar to ethylene, polyethylene. Polyethylene is CH4, that is 4 and 2 carbon atoms, C2H2, 2 carbon atoms and 4 hydrogen atoms. But polytetrafluoroethylene has 4 fluorine atoms, 2 carbon atoms and 4 fluorine atoms shown in the figure. So it is also known as Teflon, as a trade name for PTFE is Teflon, and its monomer is tetrafluoroethylene. The monomer is a gas at room temperature with a boiling point of minus 70 degrees Celsius. PTFE is prepared by two methods. In one method, it is obtained by dechlorination of dichlorotetrafluoroethane. In another method, PTFE is obtained by decarboxylation of sodium perfluoropropanate. Polymerization is carried out using emulsion method. In the polymerization process is very difficult for this PTFE polymer and releases large amount of heat and it produces explosions. So if sufficient precautions are not taken, violent explosions will take place. So in this polymerization process, oxygen is used as initiators. Properties of PTFE. So the melt flow rate of PTFE is very low and hence processing is very difficult in case of PTFE and cannot be produced by conventional manufacturing techniques. Those can be used for other polymers. It can be manufactured by powder metallurgy method, which is typical for metals. The polymer is not hard, it is slippery and it is waxy to touch and has a very low coefficient of friction. PTFE is resistant to corrosion against solvents. It can withstand very high temperatures. Applications of PTFE. PTFE is used to make non-lubricated bearings and its fiber is used to form belts, fiber cloth and similar products. PTFE is used to make pump valves, pipes where chemical resistance is required. Electrical applications of PTFE include wire and cable insulation, insulation for motors, generators, transformers, coils and capacitors. PTFE is used to make linings for trays in bakeries and other food processing equipments. Its main application is in the insulation wirings. Then thermosetting polymers. So we know the difference between thermoplastic polymers and thermosetting polymers. Thermoplastic polymers are prepared by additional polymerization, whereas thermosetting polymerization, where polymers were prepared by condensation polymerization, and it is a cross-linked and giant molecule. Thermosetting polymers, it cannot regain its original shape after the application of, after the removal of force. It cannot regain its original force. So urea formaldehyde and phenol formaldehyde are the two thermosetting polymers. Urea, the structure is CH2, N, CH2 and CO and N. Urea condenses with formaldehyde to form urea formaldehyde resins. It is also called as resins or resins. Melamine and formaldehyde can also react to give methyl derivatives of melamine. Properties of urea formaldehyde are amino resins. It is also called as amino resins. Amino resins are clear and colorless, and urea formaldehyde has better tensile strength and hardness than phenol formaldehyde, but their impact strength and heat moisture resistance are much lower compared to the phenol formaldehyde. Applications of urea formaldehyde are amino resins. In plywood industries, they are used as adhesives. Urea formaldehyde is water soluble, hence it is used as sizing agents and textile finishing resins. They find use in the manufacture of decorative laminates. In paper industry, they are used to improve the wet strength of paper. Then phenol formaldehyde, it is also a thermosetting polymer. Phenol formaldehyde is otherwise known as bakelite, hence it was developed by Henry Bakelite, so it is called by the name bakelite. It is formed by condensation of phenol with formaldehyde, so it is called as phenol formaldehyde. The polycondensation reaction can be catalyzed either by acids or bases. Properties of phenol formaldehyde: when combined with suitable fillers, phenol formaldehyde have good chemical and thermal resistance, dielectric strength and dimensional stability. These resins have low flammability, low creep resistance and low moisture absorption. Paper, fabric and cloth impregnate with resins and are pressed together to form the single sheet of greater thickness. Applications of phenol formaldehyde are bakelite. It is mainly used in the switch boxes, like the fuse materials are made up of bakelite. The bakelite resins are usually compounded with fillers such as asbestos powder or sawdust and used for molding electrical items, telephone instruments and so on. Industrial applications based on excellent adhesive properties and bonding strength include brake linings, abrasive wheels, sandpaper and foundry molds. Mixed with sand, phenol formaldehyde can find use as core binders in foundries. Shaped products like cutlery handles and toilet seats are made by phenol formaldehyde. It is used as moldings for electrical items and telephone instruments are mainly made by this phenol formaldehyde. Thank you.